Let us now look at the concept of intersection of a line and a circle. So I have a line whose equation is y is equal to mx plus c, and I have a circle whose equation is x square plus y square equal to a square. So I have not taken the general equation of a circle. I've taken a circle which is positioned at with center 0 0 and radius is a, right? That is what this means. X square plus y square equal to a square. Now, if this and this are intersecting, then they must have a common xy, right? That is what you mean by intersecting. The two lines are intersecting. What do? We actually solve them to get the common xy, right? Which will satisfy both of them. Likewise, here also we should have a common xy which will satisfy both this line and the circle. So what we do is we pick up this line and we put it in the equation of a circle. So x square plus y is equal to mx plus c, right? So instead of mx plus c, instead of y, I'll put mx plus c whole square is equal to a square, right? That is what I've done here. And when you rearrange this to make a quadratic in x, this is what you will get, right? So this is the quadratic in x. Now, if the line is intersecting the circle in 2 points, there are 3 ways in which the line can intersect it, right? The line can intersect the circle in 2 points. So this is the first point and this is the second point, and this is the circle. So let me just redraw it properly. You can imagine that yourself too. It's not very difficult. So you might see a circle, second case and third case. So in first case, the line will intersect the circle in 2 points. This is your first point, this is your second point. In second case, the line will intersect the circle in just 1 point, and that is, this is what is called as a tangent, where the line intersects the circle only in 1 point. And the third case is the line is away from the circle and it doesn't intersect at all. These three cases are reflected in these three algebraic conditions. How did we get the condition? So this is the quadratic in x, right? If this has two different roots, if this quadratic has two different roots, then that means the line is intersecting in 2 different points, because you are getting 2 x's for which this is satisfied. All those x's which satisfy this, they'll lie on both the line and the circle, and likewise their corresponding y coordinates also will lie on both. So if I have to have 2 different points of intersection, then I should have 2 roots for this, 2 different roots. When do I get 2 different roots? If I have a quadratic like this, ax squared plus bx plus c, when do I get 2 different roots? I get 2 different roots when my discriminant is greater than or equal to 0. Not equal to, in fact, it should be greater than 0. So b square minus 4ac greater than 0. So here your a is 1 plus m square, your b is 2mc, and your c is c square minus a square. So I put that condition, discriminant greater than 0, and I've got this. So this is when your line will intersect in 2 different points. For this case, your line should just intersect in 1 point. For that, your discriminant should be equal to 0. That means both roots should be the same. They should repeat. So when you put discriminant equal to 0, then you will get this condition. So this is what is the condition for a line to be a tangent. In fact, this is the condition for tangency. You will see this when we discuss tangents in detail. You will see that this very same equation will come. C square equal to a square into 1 plus m square. This is the condition for a line having slope m and intercept c to be a tangent to a circle. This is the condition for tangency. Coming to the third case, if your discriminant is less than 0, that means there are no roots to this equation. No roots means it doesn't intersect at all. The line and the circle are away. So this is when you put discriminant less than 0, this is the condition that you will get. So with this, we complete the concept of intersection of a line and a circle. I hope you were able to understand. You don't really need to remember everything. This condition for tangency you might have to remember, because at times it's useful in problems. But doesn't mean that if you forget you can't derive it, because it's coming from this quadratic. You pick up the line, put it in the circle, form the quadratic, and impose conditions of the quadratic. That's how you will get these conditions. So with this topic done, let's move on to the next subtopic.